Hi everyone, welcome back. In this video, we will see various memory management techniques. Guys, generally, if you look the main memory contains operating system, right? So this is always will be there in the main memory because to perform various kind of operations, and the remaining memory space should be filled with various processes, right? So to load various processes which are waiting at outside into the main memory, we are going to follow various kind of memory management techniques. Among those, one of the earliest technique which used to load the process into the main memory is contiguous memory allocation. And another type will be non-contiguous memory allocations, right? I mean, in general, memory management techniques are of two types. One will be contiguous memory allocations, another one will be non-contiguous memory allocations. Means, in non-contiguous memory allocations, if your process, let's say your program will be loaded at different locations, we call it as non-contiguous memory allocations. Whereas coming to contiguous memory allocation, the program, or I can say the process, will be loaded at the same location. We can call it as contiguous memory allocation. I mean, if you take the same example here, like this, right? So suppose for example, process P1 is there, which of size some 10 KB. If there is a 10 KB memory space, I can able to fit the entire process P1 at this particular location. For example, if all the processes sizes are here of type 5 KB, then you have to place actually the P1 into two parts, P11 and P12, right? That cannot be happen in contiguous memory location, whereas in non-contiguous memory location, your process can be split at more than one location, right? If I say more clearly, in contiguous memory location, process has to be placed at only one partition. I can call it as only one particular location, and in one particular location, I should not load more than one process. These are the things that you have to remember. Should not load more than one process, right? So means if there will be 10 KB of memory space is there, if 5 KB memory process will comes into the picture, 5 KB you have used, and the remaining 5 KB should not fit by other process. That defines the second point. And the first point is you should not place the process into two parts, like process P1 you have placed here, at the same time the remaining part of the space will be placed here. This should not be happen in contiguous memory allocation techniques. Whereas coming to non-contiguous memory allocation, it can happen like these 2 points. Means process can able to place at more than one location. So this will become under non-contiguous memory allocations. And this also happens. Location, right? You cannot able to load more than one process in contiguous, but whereas coming to the non-contiguous, you can able to load more than one process in a single location, right? Yes. So I can say in other words, this will be a centralized one, and I can call this as distributed, right? Your process will be distributed over multiple locations, right? So the best example for contiguous memory allocation is partition technique. Guys, in partition technique, what will happen na? If you have a memory, that memory can be partitioned in two ways once again. It can be either a fixed partition or it might be a kind of variable partition. Means, let's see this one. I have the main memory which allocated with one part as operating system, and the remaining memory is splitted or is partitioned in such a way that they have fixed size. Let me say 5 KB, 5 KB, 5 KB, 5 KB, 5 KB and 5 KB, right? Which is of fixed size. Once it has partition like that, it cannot able to modify further. This is what we can call it as equal fixed size partition. And in another variation, you can able to partition the main memory in the form of unequal sizes. There might be unequal sizes. Is it possible or not? Yes. Unequal sizes, right? So something like this will be some 5 KB, it might be 15 KB, it might be 2, it might be 10, it might be something like 7 KB, right? So fixed partition can be of again two types. One will be equal fixed partition, another one will be unequal fixed partition. So equal fixed partition I can also call it as a static fixed partition, or I can call it as multi-programmed fixed number of tasks. MFT means multi-programmed fixed number of tasks. Whereas coming to variable partitioning, I can also call it as dynamic partitioning, or I can call it as MVT, multi-programmed variable number of tasks. Hope you understood, guys. So in fixed partitioning, once the memory created in the form of partitions, it cannot again reorganize. Okay, coming to the variable partitioning, how it will be now? When you are going to have an operating system in the main memory, the remaining part is going to be splitted based on the user request, not the fixed one. For example, if there is a request with size 2 KB, I can allocate 2 KB and leftover will be as is. Next, if I got the request as 10 KB, I can allocate it. If I am getting something like 7 KB, I can cut like this, right? This is what variable part means. Based on the request, I can able to create the memory. Means I can reorganize the memory as per need. This is what we call it as a variable partitioning, right? So which means I can able to place here P1, but P1 cannot be able to place at the multiple location, because all these partition techniques will becomes under contiguous memory location. Is it okay? Yes. So this is all about the partition techniques. In the next video, we will try to look into what are the various kind of performance issues of all these fixed partitioning and variable partition techniques. Hope you understood this video clearly. Thank you.